Okay, number 8. So this one is asking us to use logarithmic differentiation to differentiate this monster. So note that it says we don't have to simplify, so that's going to be helpful. Let's write this function down. F of x is e to the x squared times cosine of x. Divide all of that by log of x plus 3 to the 5th. Okay, so in theory, if we wanted, we could do this just using product, quotient, and chain rule and not worry about logarithmic differentiation. But I would have to do product rule twice on top to get the derivative of the top. I would have to do product rule on the bottom to get the derivative of the bottom. And putting all that together would be pretty horrendous. So here's a situation where natural log would probably make our lives a lot easier. So again, I'm going to call y equal to f of x. So the natural log of y is natural log of this, x squared cosine x log x plus 3 to the 5th. And these should be absolute value bars, just in case the function goes negative. Okay. And now I can use my log rules. So now this is log e to the x times x squared times cosine of x minus natural log absolute value minus natural log of x times x plus 3 to the 5th. Okay, so I did it this step is I used the log rule that says I can split up a fraction by taking log of a divided by b is log of a minus log of b. Now I can split all the other stuff up. This is log e to the x plus log x squared plus log cosine of x minus log x. There was some confusion in class. You are allowed to take log of a log. That's a perfectly fine function. Minus log x plus 3 to the 5th. Okay. Again, both of these are minus because they came off the same fraction, so the minus would distribute. One more. We haven't actually done any calculus yet, just log. X times natural log of e plus 2 log x plus natural log cosine x minus log x, that doesn't have a power, minus 5 log x plus 3. So anything that had a power, I used the log rules to bring it down. Also, log of e is 1. So that's going to make our life the tiniest bit easier. So now d dx of log of y is equal to y over y prime. Sorry, y prime over y. Why is that? Derivative of log of y would be 1 over y, but y is a function of x, so we need the chain rule. So that gives us multiplied by y prime. So y prime over y prime over y. And now we're going to differentiate everything on this line. So derivative of x is equal to 1. Derivative of 2 log x is 2 divided by x. Derivative of natural log of cosine of x, that's going to take a chain rule. So derivative of log says 1 over cosine of x times the derivative of cosine of x, which is minus sine of x, minus derivative of log x. So this is going to be 1 over log of x. And then by chain rule, I'm going to have times the derivative of log x, which is 1 over x, minus 5, derivative of log of x plus 3. Again, this is technically a chain rule, but minus 5 over x plus 3. So what we just did seems way easier than 3 product rules all put together with a quotient rule. So now the problem said we didn't have to simplify, so y prime is equal to y times all of this stuff, which with the power of technology, I can copy, paste, and then paste again because I'm going to need it. And then y prime I don't have much room. Let's see, can I make this smaller? Perfect. Okay. So y prime is equal to, then we look back and say, what was y again? And it was x squared e to the x times cosine x divided by log x, x plus 3. And that is our hard worked on final answer.